बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलाम वालेकुम स्टूडेंट्स आज हम लोग चैप्टर नंबर 16 के रिमेनिंग 5 न्यूमेरिकल सॉल्व करेंगे। इससे पहले चैप्टर नंबर 16 के तमाम शॉर्ट क्वेश्चंस और पहले 5 न्यूमेरिकल्स हो चुके हैं। सो नाउ इट्स अ टर्न ऑफ न्यूमेरिकल नंबर 16.6. So in this numerical, a 10 millihenry 20 ohm coil is connected across 240 volt and 180 over pi hertz source. So how much power does it dissipate? इस इलेक्ट्रिक सर्किट में दो बेसिक कंपोनेंट्स ऑफ इलेक्ट्रिक सर्किट और एसी सर्किट मेंशन किए गए। एक इंडक्टर whose inductance is 10 millihenry and second is resistance which is of 20 ohm, and both are connected in series with a source whose total voltage is 240 and the frequency is 180 over pi hertz. So calculate the power dissipation in this electric circuit. So given situation where F is 180 over pi hertz, resistance 20 ohm, inductance 10 millihenry, and applied voltage or peak value of the voltage is 240 volt. So power dissipation आपने find करनी है. We know that power dissipation is equal to VI cos theta. So P is equal to VI cos theta और यहाँ करंट की वैल्यू नहीं है. So value of current can be determined by using V over Z, where Z is impedance, and impedance of the electric circuit can be determined by using R square plus XL square and whole square root. So with the help of this mathematical form, we can determine the impedance of electric circuit. But in this equation, inductive reactance is also unknown. तो सबसे पहले हमें inductive reactance find करनी है, यानी XL find करनी. So here XL is equal to omega L, and the omega can be replaced by 2 pi F. So XL is equal to 2 pi FL. By putting their values, 2 into pi into 3 over pi multiplied by 10 into 10 is power minus 3 Henry. Here 10 into 10 is power minus 3 is inductance of that inductor coil. यहाँ pi से pi cancel. So inductive reactance is equal to 3.6 ohm. This is the value of inductive reactance, 3.6 ohm. By putting this value of inductive reactance in equation number 3, impedance becomes equal to 20 square plus 3.6 square and whole square root. So impedance of the electric circuit is equal to 20.32 ohm. This is impedance of electric circuit. Now by putting this value in equation number 2, which is I equal to V over Z, where V is 240, impedance is 20.32. So the value of current passing through that electric circuit is 11.84 ampere. So this is the value of current, 11.84 ampere, and it is also required in equation number 1 to determine the power dissipation through the electric circuit. So I is equal to 11.84 ampere. Similarly, the phase angle of this electric circuit is tan inverse XL over R, where XL is 3.6, resistance is 20 ohm. So phase angle becomes 10.2 degree. So by putting all these values in equation number 1, we can determine the power dissipation. P is equal to VI cos theta, where V is 240 volts, current is 11.84 ampere, and theta is 10.2 degree. So power dissipation of this electric circuit is 2778 watt. So this is the amount of power dissipation in this electric circuit, 2778 watt. 16.7. Find the value of current that is flowing through a capacitance of 0.5 microfarad when connected to a source having 150 volt at 50 hertz frequency. इसमें अपने करंट की वैल्यू को फाइंड करना है, and this is a pure capacitive circuit where there is a capacitor having capacitance 0.5 microfarad. So current can be determined as IRMS, where V is 150, frequency is 50 hertz, capacitance is 0.5 microfarad. So current can be determined by using XC is equal to V over I. तो इसमें हमें पहले XC भी फाइंड करना है. So XC is equal to 1 over omega C, and omega can be replaced by 2 pi f by putting the values of F and C, where F is 50 hertz and C the capacitance of circuit, capacitance of capacitor is 0.5 microfarad. Hence capacitive reactance is 6369.4 ohm. IRMS, which is equal to V over XC, where V is 150 volts and XC is 6369.4. So current becomes 0.024 ampere. So this is the value of current passing through that capacitive circuit, 0.024 ampere. In 16.8, an alternating source of EMF 12 volt and frequency 50 hertz is applied to a capacitor having capacitance 3 microfarad in series with a resistor having resistance 1 kilo ohm. So calculate the phase angle. ये एक RC series circuit है जिसमें resistance 1 kilo ohm, capacitance 3 microfarad है और हमें phase angle find करना है, theta find करना है. So according to given situation, the applied voltage or the peak value of voltage is 12 volt, frequency 50 hertz, capacitance 3 microfarad, resistance 1000 ohm. Theta इसमें find करना है, phase angle मालूम करना है. So here XC, which is equal to 1 over omega C, 1 over 2 pi FC, where F is 50 hertz and capacitance is 3 microfarad. Hence XC, which is capacitive reactance, and it is equal to 1061 ohm. This is the value of capacitive reactance, 1061 ohm. So by using this value in this equation, phase angle can be determined tan inverse XC over R. Here XC is 1061 and R, resistance of the circuit, is 1000 ohm. So phase angle, which is to be determined, is equal to 46.7 degree. So this is the value of phase angle, 46.7 degree. In question number 9, which is related to the resonant frequency of an electric circuit. So in 16.9, calculate the resonant frequency of a circuit which includes a coil having inductance 2.5 Henry and capacitance of 40 microfarad. दो कंपोनेंट्स हैं, इंडक्टर जिसकी इंडक्टेंस 2.5 हेनरी है, जबकि कैपेसिटर whose capacitance is 40 microfarad. So find the resonant frequency of this LC circuit, where L is 2.5, C is 40 microfarad. Find the resonant frequency, which is 1 over 2 pi LC square root by putting their values, where inductance is 2.5 and capacitance is 40 into 10 to the power minus 6 square root. So resonant frequency is equal to 15.9 hertz. This is resonant frequency of the given inductance and capacitive circuit, 15.9 hertz. The last numerical 16.10, an inductor of inductance 150 microhenry is connected in parallel with a variable capacitor whose capacitance can be changed from 500 picofarad to 20 picofarad. एक इंडक्टर को आपने कैपेसिटेंस के साथ कनेक्ट करना है, whose value is adjustable. Minimum capacitance is 20 picofarad and the maximum capacitance is 500 picofarad. So calculate maximum frequency and minimum frequency for which the circuit can be changed. मैक्सिमम और मिनिमम दोनों फ्रीक्वेंसीज को फाइंड करना है, जबकि इंडक्टेंस 150 माइक्रो हेनरी है, मैक्सिमम कैपेसिटेंस 500, मिनिमम 20 picofarad. So find the maximum resonant frequency and minimum resonant frequency. We know that resonant frequency is equal to 1 over 2 pi LC square root. Resonant frequency and capacitance, they are inversely proportional to each other. So for maximum resonant frequency, there should be minimum capacitance. So here is maximum resonant frequency, but there should be minimum capacitance. So by putting their values, 1 over 2 into pi, which is 3.14, inductance 150 microhenry, and minimum capacitance is 20 picofarad. So resonant frequency maximum is 2.91 megahertz. This is maximum resonant frequency. For minimum, it should be 1 over 2 pi LC maximum. For minimum resonant frequency, there should be maximum capacitance, that is 500 picofarad. So it becomes 0.58 megahertz. So in this electric circuit, minimum frequency can be obtained as 0.58 megahertz and the maximum frequency can be obtained as 2.91 megahertz. So this is last numerical of chapter number 16. Now it's a turn of chapter number 17, which is physics of solids. So in this unit, we'll discuss about the properties of solids, and those properties are mechanical, electrical, and magnetic properties of solids. Physics of solids. What is physics of solids? It is the branch of physics that deals with the study of properties of solids which are mechanical, electrical, and magnetic properties. So in this unit, we'll discuss about mechanical properties, their stiffness, ductility, similarly what are conductors, insulators, and semiconductors, and what is difference between conductors and insulators. And the third one, how a substance can be magnified, and what are the categories of solids on the basis of their magnetic properties. So first of all, classification of solids on the basis of their mechanical properties. So solids are classified into three groups on the basis of their mechanical properties. Mechanical properties में इन substances की ductility, इनकी stiffness, इस पे स्ट्रेस और स्ट्रेन के दरमियान जो रिलेशनशिप है, इन बेसिस पर सॉलिड्स को तीन कैटेगरीज में डिवाइड किया जाता है. And those categories are crystalline solids, amorphous solids, and number 3, polymeric solids. So these are three groups of solids on the base of their mechanical properties. ये इनके structure की base पर इनको classify किया गया. Now their properties are, first of all, the properties of crystalline solids. So what are crystalline solids? Such solids in which molecules are arranged in a regular manners are called crystalline solids. ये ऐसे solids होंगे जिसमें atoms और molecules एक regular manners में, एक regular fashion में arranged होंगे. So these solids are called crystalline solids, and their arrangement, their order structure will remain same throughout the crystal. इनकी ये जो अरेंजमेंट है इन क्रिस्टलाइन सॉलिड्स में वो स्टार्टिंग से लेकर एंडिंग तक सेम रहती है, इनमें डिफरेंस नहीं आता. So such type of solids are called crystalline solids. And further characteristics are, in such type of solids, atoms are not stationary, but they vibrate about their mean position. कि ये move तो नहीं कर सकते from one place to another place, but they can vibrate about their mean position. And number 4, they have definite melting point. Crystalline solids possess definite melting point, a sharp melting point. And number 5, there is a strong cohesive forces between atoms and molecules. That's why they can just vibrate about their mean position. They can't change their place from one point to another point. They can just vibrate about their mean position under the action of these strong intermolecular forces or cohesive forces between them. And their examples are, in case of metals, iron is a crystalline solid. Similarly, zinc, copper, they are crystalline solids and they categorize in metals. And in case of ionic compounds, sodium chloride, which is a cubic crystal, so it is a crystalline solid. And in case of ceramics, zirconia is a crystalline solid. So these are examples of crystalline solids in which atoms and molecules, they are arranged in a regular manners, and this arrangement remains same throughout the crystal. पूरे crystal में इनकी arrangement disturb नहीं होती, ये same रहती है. So such type of solids are called crystalline solids. And other are amorphous solids, where amorphous means shapeless. Amorphous means shapeless. They have no definite shape. There is no regular arrangement of the molecules. So they are opposite to the crystalline solids. Crystalline solids में regular arrangement थी throughout the crystal, जबकि amorphous solids में इनकी arrangement regular नहीं होगी. Throughout the crystal, they have no regular arrangement of the molecules. Number 2, amorphous solids are more like liquids with the disordered structure frozen in. यानी इनकी जो characteristics हैं वो liquids की characteristics के साथ match करती हैं. So amorphous solids are more like liquids with the disordered structure frozen in. यानी इनका जो disordered structure है वो present होगा इनमें. Number 3, they have no definite melting point. But in case of crystalline solids, they were having definite or sharp melting point. In case of amorphous solids, they have no definite melting point. For example, ordinary glass at ordinary temperature has disordered structure. On heating, it start melting. जब आप इसको हीट करेंगे तो ये मेल्ट होगा into paste like state. Initially it would be in the paste like state, and then it changes to more viscous liquid at approximately 800 degrees centigrade. So this is the change in state of an ordinary glass at different temperatures. Initially it melted into paste like state and then changes to more viscous liquid at 800 degrees centigrade. So that's why amorphous solids have no definite melting points. So these amorphous solids are also called glassy solids. इनका alternative name है amorphous solids को glassy solids भी बोला जाता है. And the third type are polymeric solids. Polymeric solids have structure between ordered and disordered. Order means crystalline and disorder means amorphous. So polymeric solids are those solids whose structure lies between ordered and disordered structure. So that's why they are called partially or poorly crystalline solids, क्योंकि इनकी कुछ characteristics क्रिस्टलाइन सॉलिड से मैच करती हैं और कुछ अमॉर्फस से मैच करती हैं. सो आप इनको पार्शियली और पुअरली क्रिस्टलाइन सॉलिड्स भी बोल सकते हैं. सो दे आर कॉल्ड पॉलीमेरिक सॉलिड्स. These polymers are formed by a chemical reaction called polymerization reaction. So with the help of this reaction, a long chain massive molecules can be obtained. So this reaction is called polymerization reactions. Characteristics of polymeric solids are they have low specific gravity compared with even the lightest metal. अगर हम लाइटेस्ट मेटल के साथ भी इनकी स्पेसिफिक ग्रेविटी को कंपेयर करें तो इनकी स्पेसिफिक ग्रेविटी उस लाइटेस्ट मेटल की स्पेसिफिक ग्रेविटी से भी कम होगी एंड दे शो गुड स्ट्रेंथ टू वेट रेशियो due to their low specific gravity. Even they have low specific gravity, but they can show good strength to weight ratio. So here what is meant by specific gravity? Specific gravity can be defined as the ratio of density of a substance to the density of a reference substance. Usually water can be considered as a reference substance. So the ratio of density of a substance to the density of a reference substance is known as specific gravity, and polymers have low specific gravity but they can show good strength to weight ratio. यानी इनका अपना weight तो कम होगा but they can show good strength. So these are called polymers and their examples are polythene, polystyrene, nylon and natural rubber. These are examples of polymeric solids. So these are classification of solids on the base of their mechanical properties, जिसमें हमें इनके स्ट्रक्चर को डिस्कस करना है, हमें इनकी डक्टिलिटी को डिस्कस करना है या फिर लायबिलिटी को डिस्कस किया जाता है. So these are classifications of solids on the base of their mechanical properties. Thank you.